Hello and welcome to Engineering Problem and Solution. Today we are going to look at the topic called binomial distribution probability, and we have one question here. And let's look at this question and we'll start doing the solution on what is the question is asking about. So example 1, it says one of the machine is causing quality problem as 8% of the engine parts produced on this machine has been found to be defective. Find the probability of finding 0, 1, 2, 3, and 4 defective parts in a sample of 50 parts. So you can see here the question is asking that none of the parts are defective, one part is defective, and two parts is defective, and so on up to 4 parts are defective in the sample of 50. We also need a probability, and the probability is given us as 8%. Now, quickly, we need to understand what is binomial distribution. Now, when you applying the binomial distribution, it can have only two events, whether it's going to be pass or it's going to be fail, or it's going to be hit or it's going to be tail. So any event will have a chance of happening basically one or other. Okay, so using that concept, we have a formula for the binomial distribution. So let me write this formula first, and then I will go with the example and then talk about what is given in the example. So the general formula of binomial distribution probability is given as we can say P, the probability of the event, or we can say, we'll say the probability of that event, which is K, can be calculated using your combination of your number of sample and the event times with whatever probability of the defection or defective things has been given, with the power of that event times your opposite, which is not going to happen, that probability, the opposite of probability, which is 1 minus the probability which is given, and then remaining whatever is not covered in the sample, which is n minus k. So this is the formula for the binomial distribution, and where you can say k is nothing but is 0, 1, 2, so on up to n. So how we can write this formula is the k can be event which is happening for A, okay, occurs k time, and also remember there is B, because there is always a two case in a binomial distribution. Either is going to be happen or is not going to happen. So it's going to be pass or it's going to be fail. So if this is a pass, then this is going to be fail. So if A is a pass, or the condition which we are looking at, then B is the condition which we haven't looked at, which is B occurrence n minus k times. So once we looked at the formula, let's understand what is given to us. The first thing in the question we can see here is the 8%. The 8% which is given to us is the percentage of the parts which can be defective in that machine. So the P value is given to us is 8, which you can see in the question here. And then it is asking that find the probability of the parts which is defective, which is 0 means none of the parts are defective, one part is defective. So your k will have each case is going to be 1 times 0, 1 times 1, 2, 3, and up to 4. And we have a sample, means your n, the value of n is going to be 50. So once we understand what is given to us, let's work on now. So solution, I'm going to go back to white color. So solution, so we'll go with this one by one. Okay, so I will say finding, so we'll say basically finding probability, for each case. Okay, finding the probability. First case is going to be, let's say case 1 is 0 parts or 0 faulty parts or defective parts, you can say. So I will say here faulty parts out of 50 sample. Okay, so that's the first case we're looking at. So our formula is going to be P, our K equals to 0, because our even for this case is going to be 0, and the formula we have is a combination which is 50 C and then 0. If you use a calculator, you can use that way, times your probability P is given to us, which is 8%. Remember that is percentage. Okay, is 8%. You have to convert that into decimal. So if you divide by 8 by 100, you will get 0.08. Then what's the power we need? We need power of 0 because K is 0. Times we will have 1 minus 0.08, the power which is 50 minus 0. So we just need to use this in calculator and we will get. So let me write this again nicely. So 50C0 times 0.080, which is going to be nothing than 1 because power of 0 is 1, and then we have 1 minus 0.08 power 50. So if we use this in a calculator, you can use the NCR, which is in division section here. So for that, simply put your highest number, which is 50, and then press shift this. You're going to see that there is a C, which is your combination, and then put the value which we are after, which is 0, times, since we have 0.01 power 0, which is going to be 1, we don't need to write that, and then we can write 1 minus 0.08 power. So I need to have a power, basically power of 50. So if we do that, we can get the value which is 0.015. So let's go up to 3 points after the decimal. So we got 0.015466, and if we multiply with 100, we'll get in percentage, which is 1.55%. So that's the percentage, which is so that means clearly we can see that there is very low chance of parts which is going to be faulty. So there is very low chance of none of the parts is going to be faulty, so which is not bad. So let's go to the case 2. Case 2 is basically again finding the probability. I'm not going to write that. So case 2 is finding the probability when one part is faulty. Okay, one faulty part. Okay, so let me get rid of this part because there is 0. All right, so now same formula, but the case we have this time is different. So P K equals to 1. So wherever you use last time 0, this time it has to be basically 1. So 50 C1 times 0.08 power 1 times 1 minus 0.08 power 50 minus 1. So if you use this in a calculator, again going back to calculator, we should put this as a 1, and there we need a value which is 0.08, power is 1, and then if we do the equals to, we got basically 0.0618. so let's use that. We got 0.06725, something like that, and then if we multiply with 100%, we got 6.72%. So we can see that as we increase our parts defective, the chances is increasing as well. And which makes sense, because if you look as a total 50 parts upon 50, then definitely the defective parts will be present there, because there is big number of sample you are looking at. So as the sample and the events are increasing, the percentage is also increasing, which is fine. Now case 3 is we're looking at two faulty parts. Okay, so same formula, pk equals to 2 and then 50c2 times 0.08 power 2, and then we have here is 1 minus 0.08, 50 minus 2. So if we use this in again calculator, we will get the answer as 0.14326, and thus if you multiply with 100%, we'll get 14.33 if we round this up to 2 decimal point, and that's our answer. Similarly, we'll go to case 4 now. Case 4, which is for 3 faulty parts. So we're going to change that k to 3, and then 50c3 times 0.08 power 3 times 1 minus 0.08, 50 minus 3. And again, if we use this in a calculator, we'll get the answer as 0.1993, and then multiply by 100, we'll get 19.93%. And that's our for 4 defective part, 3 defective part. And lastly, for case 5, we are going to find for the 4 faulty parts. Same formula, same principle, k equals to 4. Wherever you put last time 3, we put 4. 0.08 power 4, 1 minus 0.08 power 50 minus 4. So if you use this in a calculator again, you are going to get 0.2037, and if you multiply with 100, you are going to get 20.37%. And by doing that, we complete our question.